morning, everybody, and welcome to today's webinar on GE's Water and Process Technologies Challenge, Innovative Central Tube Connections. My name is Casey Shapiro, and I will be your host and moderator for this webinar. So there will be 5 parts to this webinar, and now I'm going to briefly go through the agenda. First, we'll provide the speaker introductions, and then we'll provide an overview of the challenge. After that, we'll present 6 frequently asked questions of the challenge, and then work through the live audience Q&A. To participate in this live Q&A, please submit your questions at any time through the Q&A chat box. We will collect and present these questions through the live Q&A section. If we don't answer your question live, please note that we will be transcribing and answering all questions asked during the session, and then posting them on the challenge forum for viewing at a later date. Finally, we'll wrap it up with information on what you can do today for the challenge, including where to register, how to stay connected, and how to submit your proposal. Now, I'm pleased to welcome the following speakers to our webinar this morning. From GE, we have Lisa Ralph, Open Innovation Operations and FastWorks Integration Leader, John Peichel, Technology Leader, GE Water and Power Technologies, and from 9 Sigma, we have Nick Cassandi, Program Manager. So the topic of today's webinar is GE's Water and Process Technologies Challenge, Innovative Central Tube Connections. We at 9 Sigma, as representatives for the General Electric Company, seek 3D design submissions for novel means of connecting the components of a plastic central tube assembly. Design should improve upon current system limitations by reducing the number of components, improving ease of installation, and reducing the cost of the overall system. Now let's hear from Lisa Ralph on GE's vision for this challenge. Go ahead, Lisa.
Hi, good morning. Can you hear me?
Go, thanks, Lisa.
Okay, great. Welcome, everyone. Thank you so much for joining. We are thrilled that you are here. So, my name is Lisa Ralph. I'm working in GE Corporate on our Open Innovation and FastWorks team, which is essentially codifying the process to drive cultural change across our businesses and to usher in a new mentality to create and innovate in a smarter, faster, more innovative and efficient way. So open innovation is something new for us to think that, hey, maybe we should be reaching outside our organization. There's a lot of brilliant minds out there. So being able to collaborate with these brilliant minds, like all of you on here, is something that we're excited about because we're putting that collaboration against our highest value problems. And this is really neat because what it's allowing us to do is really perforate the walls of constraints. So it's kind of shattering the windows of how we normally innovate and how we normally look at things and taking new perspectives and new ideas and integrating them. What it's doing is really allowing us to reframe what's possible. So this partnership between you and between us is really allowing us and providing a vehicle to bring better, more efficient outcomes to fruition, which is really cool because not only is it developing that idea, but actually making it happen. So we're thrilled for this partnership to be working with you, for you to potentially be working with us, and that this ability to collaborate together, and not only just to be collaborating, but to actually be working on really high impact problems to develop better, more efficient outcomes. This is really allowing us to together define tomorrow today. And then so now that we've said, yes, we're obviously very excited you're here and interested in this challenge, would love to tell you a little bit more about that. So if you can actually move to the next slide, what are we excited about? It's the innovative central tube connections. So now let me preface this with the fact that my background is in economics, not in a very technical scope, so please ignore my non-technical point of view. But from here, what I think is really important is that these central tube connections, what we'll be talking about a little bit later in more detail, is that they're such a vital part of the next step, which is the spiral bound membrane. And from there, these spiral bound membranes are a key building block of GE's advanced water systems. So what's interesting here is that, yes, it's this tiny component that ladders up into this giant overall system, but what's neat is these are so expansive and used across the globe, which means your solution, if it's end up being selected, could literally be used and implemented all over the world, which is very cool. So these central tube connections, what actually are they? What they do essentially is join together the membranes of the spiral wound membrane. So right now, each connection is made up of several independent components that are essentially squashed together to create this tight, leak-proof seal. So what we're asking you to do and to define is to find the most viable means of connecting these components. So essentially, improvements could be in terms of a fewer number of components. Two, it could be in terms of improving the ease of installation, which is helpful again because there are so many of these across the world, as well as and easily reducing costs. So with that, let me turn you over to hear more about this expansive, exciting opportunity to a great technical mind and colleague of mine, John Peichel.
Thank you so much, Lisa. John, it's your floor.
Much. I'm coming through okay?
Yes.
Thanks, Lisa. So when I'm a technology leader in GE's Water and Process Technologies division, and my responsibility is the research and development of products associated with filtration, with membrane, with e-separations technologies. And in the membrane, one of my primary focuses is on this spiral wound reverse osmosis element technology. So just to give you a perspective on where this technology is used, we have this slide showing the progression from an actual system that GE manufactures that is used in reverse osmosis water treatment. Reverse osmosis is used anytime someone needs to purify water and remove salt using an RO membrane. And RO membranes use pressure, so piping, seals, configurations are very important to the overall process. In the skid that's depicted in the upper left-hand picture, we have a complete reverse osmosis system that has an inlet cartridge filter, it has a high-pressure pump, it has a number of 8-inch diameter, about 12 feet long, spiral wound membrane element housings, and the connection we're talking about is inside those housings, and it is the configuration of a spiral wound membrane element. From a historical perspective, spiral membrane element technology came into water treatment in the 70s, and as certain efficiencies in cost and standardization came about, it quickly grew in prominence in the 80s, and by the 90s it had overtaken the predominant hollow fiber membrane technology. And so what makes this technology unique is the fact that we take a membrane, which is flat sheet, and we spirally wind it around a central tube. And that central tube is where we collect the purified water that goes through a membrane, where we've removed the salt by it passing through the membrane. One of the ways that we make these systems cost-effective in this industry is we make a standard 40-inch long, 8-inch diameter spiral wound module, and we put multiple modules connected together in a housing so that we can take advantage of the expense of a single housing manufacturing with multiple membrane elements made of a standard configuration. But this means that between every spiral wound element in a housing, there is an interconnector. In the central picture, you can see the interconnector protruding out the end of one of those spiral wound elements. When that element gets inserted into that high-pressure housing, we'll then mate to it a second spiral wound membrane element. And then the water that is purified by each of those individual elements will be conveyed from the center of the element through that plastic interconnector, through the center of the next element, through the center of the next element, until it's connected to the end of the high-pressure housing and is collected in the manifold, which collects all of the purified water. And so our challenge is to come up with a way to replace and or eliminate that central tube connection, which is depicted in the lower right-hand picture. And so what we have there is two central tubes, which are just the ends of a 40-inch long tube, connected by approximately a 5.5-inch long, 1-inch diameter interconnector with 4 O-rings, 2 at each end. And so there are a number of ways that are used to connect pressurized pipe in water treatment. And what we're looking for is a way to eliminate that connector and perhaps integrate the connection into the ends of the central tubes such that we could eliminate a part, reduce the places for leakage, make it easier for customers to install and remove the elements, both when they're new and at the end of life, and to make it compatible with these existing systems, which are very prevalent throughout industry throughout the world. One of the reasons why we like this challenge is that an innovative idea in this space can be applied both to existing system installations and to new systems, and it can bring lower cost, higher robustness, and better ease of use for customers in applying reverse osmosis membrane technology in water treatment. The next slide. So I know many of you who are participating in the challenge really have expertise in design or ways that plastic or three-dimensional objects or people work with materials. And so just to make sure that if you're not familiar with how water treatment piping systems are built, I wanted to give you a cross-sectional view of exactly what's going on at the interconnector connection inside a housing. So if you look at how we build up a building block for water treatment, we start on the very bottom of this slide with a stainless steel or a fiberglass pressure vessel. And these vessels are anywhere from a meter in length to 6 or 7 meters in length. And that allows us to put as many 40-inch long elements into a single housing as the housing is long. In this picture, I've exploded diagrammed 3 elements to be installed in this particular housing. And in between each of those 3 elements is a connection that allows us to connect the central tube where the purified water is collected, and it will then be transferred to the very end cap as purified water. Water that is not purified actually exits the housings through the side pressure port depicted in the lowest picture. So if I take that housing and I actually show you exactly how those 3 elements are arranged in the housing, in the very center diagram, I have 3 elements depicted in the orange color, and they're wrapped around a 40-inch long central tube, and between the ends of the housing and in between each of the elements is this interconnector. And the interconnector fits inside of the central permeate tube, and that inside tolerance is such that when we put 4 O-rings, 2 on each end, the pressure compression on that O-ring is what seals from the outside dirty water to the inside clean water that is flowing inside those tubes. And so the goal is to connect those 2 tubes and remove that interconnector with those 2 O-rings. Now, your solution may include an O-ring, it may include some other type of sealing mechanism, but it has to withstand the operating pressure of reverse osmosis, which is approximately anywhere from 100 to 300 psi in the outside of that housing. And one reason that O-rings are used is because if you set up the tolerance, their compression is very good at sealing. Your design has to incorporate that same sort of ability to seal from the high operating pressure reverse osmosis and prevent leakage of the dirty water into the clean water inside that tube. Okay, I think I'm going to pause there with that description and pass it on to the next slide and the next presenter.
Thank you so much, John. John. So with that, we're going to go ahead and move on to address 6 frequently asked questions for this challenge. On to the next slide. The first one is, when is the deadline to submit an entry?
So this is Nick Cassandi. The deadline has been set for December 31st of this year. Just for everybody's reference, we will be offering an extension on that into January. The exact date has yet to be determined, but you should expect in your emails some sort of announcement within the next few weeks to give an indication of the exact date. So we do understand that New Year's Eve is not the ideal time to deadline these types of challenges, so you will have at least an additional week or two built into the opportunity.
And how do I submit an entry?
So all entries need to be submitted online through the challenge webpage. It's linked there. If you've gotten any emails from us, obviously you probably have the links and web information as well. All entries do have to be submitted through this portal. We can't accept them via email. So when you're preparing your entry, please keep in mind that you will have to go to the website, submit it through there, and you should receive the confirmation through that.
Great. I included my entry.
The primary piece of any entry that's submitted is going to be the CAD files or the 3D design files. At this time, we're accepting a variety of file types, primarily STL, IGS, IGES, STP, or STEP format. Those all need to be considered when you're submitting. We will not be submitting things in the form of a standard JPEG or any sort of image files. We need to have actionable documents for GE to be able to reference and work from. This will also ensure continuity and just make sure that everybody's on the same competitive platform. Additionally, we want any relevant background or supporting data that you have regarding your design. This could be in the form of simple background related to your organization, but also any explanation that you have for your design and how that would improve upon the current standards.
To submit samples or prototypes?
No, you do not have to submit samples or prototypes for this. Some people may, within your internal processes, need to develop those for your own efficacy, but GE does not require those, nor will 9 Sigma be accepting those on behalf of GE.
Do my IP rights if I accept a prize?
If you accept a prize, you do give up your IP rights. The challenge rules explicitly state the information around this, and you can see it referenced through the link here. It's also on the challenge webpage. Making a submission does not give up your IP rights, but accepting a prize does. And again, that's detailed further in the challenge rules.
And when will GE announce the winners?
GE will be announcing the winners here in March of 2015. An internal team of experts will review all the entries, compare, and make their top selections for announcement then.
Great. We're going to move on to the Q&A, live Q&A session. We will open the session up to any questions from the audience. Please continue to submit your questions to the Q&A chat box. We will take the rest of this time to answer them live. If we don't get to your question, don't worry. We are recording this, and we are going to archive it and transcribe it so that all questions and answers will be made available on the challenge site following the webinar. So let's then take any questions that we have via the chat box now. Okay, so we received a question that was answered during John's presentation, but we want to make sure that we clarify again. So somebody had asked, I would like to clarify if we have to develop an efficient connection between the center tubes on either side and the interconnect. So, yes. John, would you go ahead and clarify that further?
Yes, I will. So we're trying to replace the interconnector, and so the small 5-inch long, 1-inch diameter piece of plastic with the 2 O-ring grooves, that is what we refer to the interconnector. That's our standard industry term for it. We're actually trying to remove that piece and remove the 4 O-rings and incorporate the connection into the central tubes that are part of the 40-inch long module. So it's not necessarily to connect between the interconnector and the central tube, but to actually replace the interconnector and connect from one central tube to the other central tube.
Okay, great. And another one that is going to go right back to you, John. How many times do you expect it will be refitted?
Most membrane elements in the industry are installed once and removed once. So you end up attaching the connection and then removing the connection. There is an ability to take elements and move them from one system to another, but I would say the occurrence of that is very low, less than 5%. And even if they did remove and reinstall, it may only happen once or twice in an element's life cycle. Typical life cycle for these elements is anywhere from 2 to 5 years. Once they're installed, particularly in the application that we're targeting for this innovation, we would not expect them to be removed during that life.
Great. We have one more right back to you, John. What is the stack pressure end-to-end?
Okay. So I think this question is referring to as we put 3, 4, 5, 6 to 7 elements in a housing, and we're flowing feed water across those elements to make contact with the membrane. The typical pressure drop across one of those 40-inch long modules is anywhere from 2 to 4 pounds of drop. So in 7 elements in a housing, we can see anywhere from 20 to 35 pounds of pressure drop. Obviously, we'd like to have lower pressure drop as possible, but as elements get dirty, as they load, or we go to more aggressive applications, the pressure drop can be higher. So I think if you think about the compression pressure being anywhere from 20 to 35 pounds of pressure, PSI, that would give you a rough idea of stack pressure end-to-end.
Great, thank you. One more. Is there bending or side loading other than external pressure?
I believe that that is referring to the compressive pressure. And one of the reasons we like the tube, the circular arrangement of a plastic tube is when we put 600 PSI in seawater or 800 PSI in seawater applications, the same tube structure is very robust and does not collapse. And so the only pressure we really have is that compression pressure, which is the pressure that's in the vessel that is pressurizing onto that central tube. In this design innovation, we're looking at much lower pressures in the 100 to 300 PSI range, which is typically used in treating brackish water, because we think that that would be a fair place to start with such an innovation. And if the innovation is capable of higher pressures, we could expand it down the road.
Great, thank you. John, you're very popular. This one again is to you. Do we need to have stability in the end-to-end dimension of the connection system?
No, but when we put into a fixed housing, we do want the overall stack-up tolerance to stay within that 40-inch end-to-end dimension. If there is a need for some flexibility, we can shim at the upstream end of the membrane element stack, but we don't require any flexibility. But sometimes with our current applications, we see vessels that have been in service stretch, and if the elements compress, then we end up having to make up the difference with a shim on the upstream end of the housing. But that would be out of scope for the need in this challenge.
Okay, great. And what is the temperature range?
Coldest temperature that we operate these systems at is above freezing, so 35 degrees Fahrenheit. The highest temperature we would run a brackish system at is about 105 degrees Fahrenheit. Typical operating pressures really range from, say, 50 degrees Fahrenheit to about 80 degrees Fahrenheit.
Great, thank you. And are they recycled and or recyclable?
No. Some people will take used elements and they will clean them and then reinstall them into a system that has less aggressive treatment requirements. I would say that it happens with less than 10% of the product in the entire marketplace. Typically, when a membrane element is end of life, it is disposed of.
Thank you so much, John. So we have a few more minutes. If anybody has any last bits of questions, sorry, we got one more in as I was speaking. So does the proposed design have to allow use of the existing connector?
No. In fact, if the proposed design did not use the existing interconnector, that that would be even more innovative, and that is what we're looking for. We realize that there will be required some adaptation of the existing infrastructure to a new way of connection to the end of the vessel, and it's out of scope for the design challenge submittal. We really want people to focus their innovation on the connection between the elements, and we would consider the design challenge of connecting it up to our existing variety of end caps that are part of the housing to be out of scope and something that we would do as part of the implementation. I see another question on the website asking about the current materials of construction for the central tube and the interconnector. The current highest volume that we use is ABS plastic. We do have polysulfone plastic, and we do have Norel glass-filled plastic, but the highest volume is injection molded ABS plastic.
Great, thanks for jumping in there like that, John. That was appreciated. So we have one more. Do they sometimes use tools to assemble and or disassemble? Do they get caked up with calcium, etc.?
Some knowledge of water treatment. Yes. Typically, in the standard configuration that we're trying to innovate off of here, the only tools are really required to remove the end cap of the housing. And once the end cap is removed, the interconnectors, because they're just compression O-rings, can be removed by hand. That's not to say that people who have used elements who do have calcium carbonate precipitation or scale can sometimes be very difficult to move. And there's very creative things, from pullers that use winches or pulleys to people that use more physical forms of removal. That typically destroys or just the element, and is not, when that typically happens, a person is typically just trying to remove the fouled element from the housing and put a brand new one in. We consider it to be that extraneous. There is some connection innovation on the market that does require a tool to connect the elements. We would like our innovation to be toolless, but we certainly understand that if the innovation helps with a number of the other challenges we laid out there, just because you require a tool doesn't mean it's a bad idea. We still would welcome that. And if the tool integrated with the innovation makes sense, that's what we're looking for.
Okay, great. So if we don't have any further questions, we can go ahead and start to wrap this up. If you have any last-minute questions, we do have some more time left, so please feel free to submit them, and we can answer them after we go through this next bit of slides here. And if not, if we don't answer your question live, again, we will have them available for you after the fact. So let's move on. We want to go ahead and thank everybody for participating today, especially to John and Lisa and Nick for your expertise and your time. As I said just a bit ago, any questions, again, answered not live, or not answered live, I should say, will be available with the recording of this webinar in the challenge forum on the challenge website following this webinar. So what can you do today? Definitely visit 9sites.com and Innovation Contest. You'll find this specific contest there. Click on that and you'll go to the challenge website. Register to receive updates, view the FAQs, and join the community. All on that page you'll be able to see and participate as much as you possibly can. When you visit that page, you'll see everything available to you. Go ahead and stay connected via the community forum. Again, on that page, you'll see everything you'll need once you visit there. And then, of course, obviously, submit your proposal. The deadline for submission is December 31st, 2014, 5 p.m. Eastern Time. As Nick did say, though, there will most likely be an extension, and we will be letting you guys all know that as soon as possible. Sorry, we had one last question, but I think I can answer it offline. Again, thank you so much for everybody's time today. We really appreciate it. Again, one last reminder that it's being recorded and will be made available on the challenge site. Thank you again so much for attending, and thank you to the speakers for their time and expertise. We appreciate everybody's time, and we really look forward to receiving your submissions. Thank you so much. Have a great day.
The host has left the meeting, so at this time, the meeting will come to an end. Thank you, and goodbye.